All right, so good afternoon. I'm Rob. This is just enough LaTeX to be dangerous. So we don't have a lot of time. I'm going to try to give you at least enough motivation to believe that you want to use LaTeX and why all of your advisors are so crazy about making you use LaTeX, and then give you enough to be dangerous. So the why. So I wanted to start sort of non-traditionally and just say like why the heck we're making you do this. The first thing is we really want you to invest the time now because it will save you a lot more time in the end, right? If you don't believe us, ask some of the folks that are further ahead of you in the graduation cycle, and they will probably sing the praises of LaTeX. And a side benefit is you can laugh at all the people who aren't using LaTeX and getting hung up in the thesis processor's office. So just pragmatically why you might want to use LaTeX is it's going to make your life a lot easier, right? So if you don't believe me, talk to some of your fellow classmates. Also, just from a practical standpoint, citations and doing references are a breeze. LaTeX is highly customizable, it's scriptable, and it's open, portable, and future-proof, right? So at least some of us are old enough to have written, a document in like WordPerfect or God knows what, right? And there's not really a hope on God's green earth of opening that today, right? So LaTeX has been around for a long time and will be around for a much longer time. So the next thing is the philosophy, right? So you really got to try to get like the idea and the gestalt of what LaTeX is all about, right? So the one point that I want to give you is that LaTeX is all about focusing on the content and not the formatting, right? In fact, it should allow you to free yourself from worrying about the formatting. Many of you have seen people spend a lot of time doing things like PowerPoint engineering, right? This is sort of the antithesis of that. All you're going to do is look at the content. And in essence, what we'll do is we'll delegate all of the formatting to a set of rules that are contained within something called a style file. Then we're going to write our document in plain text, just like we would write code for C or Python or anything like that. And then LaTeX plus this style file figures out the rest. And by the rest, what I mean is it figures out all of the spacing, it figures out the formatting, it figures out how to put this here and put that there. It does all of the numbering for you. It does all of the citations for you. It does all the tables for you. It does all the image placement. And when you go and move stuff around in your document, it all remains consistent. One of the most frustrating things I've found using Word is if I, say I add a citation somewhere in the middle of my thesis, and then all of my citations are immediately out of order, and Word's putting in tabs, and heavens knows what it's even doing, and you can't even figure out what it's doing. This will be much easier and much more of a deterministic process, right? Like it does what you might expect. And then again, along this lines of the LaTeX philosophy, just like Unix, this came out of Unix, it's a small set of tools, right? So it's not this big monolithic environment, right? So as an example, Tech is not an editor, right? That's a separate tool, okay? And we're going to see examples of all of this. So there's the NPS style file. This is essentially what is in the thesis processor's brains. It encodes all of those rules that the thesis processors spend so many nights looking at your thesis and enforcing, right? So one of the nice things about this style file in theory is that it should allow you to sail through the thesis processor's office. At least anecdotally, my students have a much easier time getting through the thesis processor's office than some other students, right? And this is because you've focused on the content. You haven't, you're not worrying about, okay, is there a space here? Do I need to move this figure around? Are my tables out of order? Things like that. And again, there's this idea of not engineering for presentation. Focusing on the content allows the contents of your thesis to be better. And then you have this side benefit of laughing at your friends who are using Word. So to re-emphasize, what is LaTeX, right? So LaTeX is a markup language. It's a word processor. It's cross-platform, so it doesn't matter if you're using a Mac or a Linux-based PC or a Windows-based PC. And it's open, portable, and future-proof. As I said, it is the core of any LaTeX document is going to be just plain ASCII text. Okay, so there's not a lot of chance that you won't be able to open this in the future. and what it is not. It's not Wysiwyg, right? So what do we mean by Wysiwyg? We're talking about, what you see is what you get. This can be something that's frustrating for most new people to LaTeX because you're used to Word, right? What you see on the screen is what's going to get printed out, right? Here, again, I've said it like 3 times, but it's really the key point, and that's why I'm emphasizing it. You're going to focus on the content and not the formatting. So it's not an editor. So practically, getting started, if you were to leave today and try to do some of the things that I'm going to talk about, the first thing that you'd have to do, obviously, is to install LaTeX, okay? This is also, I believe, in my opinion, a confusing thing. It's sort of like saying install Linux, right? What do you guys do when someone says install Linux? Well, there's lots of different distributions out there, right? There's Ubuntu and Fedora and some other stupid Linux distribution. So in the same way, you're going to have to make a choice. My colleagues and I, Mark and Tim Chung, have recommended TechMaker as the easiest choice for newbies. The reason being is that it's cross-platform, it includes an editor, it includes some syntax highlighting, it includes things like a preview, so on and so forth. That doesn't mean you have to use it, right? In the same way that some people use Fedora and some people use something else. In this demo, I'm going to use MacTech. Okay, it's just another distribution of LaTeX. So that's number 1, install LaTeX. If you don't know how to do that, just grab TechMaker. The editor, it can be anything. In the same way you can write your Python code using Vim or Emacs or Ed, you can do it here the same way. Okay, so in this demo, I'll probably just use Vim. And then you'll want to obtain the NPS Thesis template. And then this template is actually pretty good because it includes a whole bunch of ancillary materials. There's a bunch of documentation. There's a whole bunch of things to try to get you started. So you can, when you get stuck on something, like say there's something that I don't have time to cover, like doing a table, something like that, this would be a good place to look. There's tons of online resources. Okay, so let me pause right there. Are there any questions about LaTeX and the philosophy before I get into a mini demo? All right, very good. So I want to cover a few things. Again, this is just enough to be dangerous and to impress your significant other at home. So we're going to start with a minimal example. Okay, so I'm going to move this over here. As I said, I'm just going to be working from the command line. So I've got this directory here, and I'm going to start by editing a file, much in the same way as you would start writing a program. And some of this you're just going to have to accept as magic, like magic incantations, right? And it'll make sense later, right? So just sort of, suspend your disbelief for a few minutes as we go through all of this. So I'm just going to call my file, we'll call it rob.tech. And the first thing that we need to tell LaTeX in the markup is what kind of style file we're writing. So LaTeX has some built-in types of styles, things like articles, and that's exactly what we're going to tell it. So I'm going to start off by saying document class article. Okay. Now this is going to be some typical formatting that you'll see, where you have this backslash, some keyword, and then these curly braces, okay? So in here, we might have put something other than article. For instance, we might have put the NPS class template in there. Or if I was writing a paper for a conference, I might have put it in there. Which, by the way, reminds me that another reason I should have put this on the intro slides, that I have my students use LaTeX, is because when we get to the point of publishing, when we write papers for academic conferences, we always write them in LaTeX. And it makes it very, very easy just to rip out portions of your thesis and slam it into an academic paper and just change the style file. The content stays the same, but all the formatting then adheres to the style that the conference wants to see for that particular conference. So here, all I've done is told LaTeX, well, I haven't told it yet, but I've written down in this markup that in fact I'm going to write an article. And then I'm going to have these keywords that say begin, right, so begin document and end document, like that, okay? This is also something you'll see commonly in LaTeX. There might be begin table or begin figure and then a corresponding end. If anyone has seen other markup languages, such as HTML, this might look very familiar, or at least in the way that it works. Now in here I can start just writing my document. So I could say, with this thesis, we definitively show that P equals NP and that cows are round, something like this, okay? So we can just write, and a thing to note, again, if you've had experience with other markup languages, is that things like spaces and line breaks are irrelevant, okay, like that. And if I want to put it in a comment, I can precede the comment with a % sign. So I can say this is a comment. All right, so I've written my first minimal example of a LaTeX document. So now you might say, Rob, what on earth is this? What do I do with this garbage? Well, it's going to be similar to, again, writing a program. In this case, what we have to do is run it through LaTeX for it to process the markup and generate a PDF. If you're using something like TeXmaker, that's just going to be a click, right? You just say click and it does it, right? I'm just doing it by hand to show you that all of these tools are decoupled. So here, I'm just going to say PDF LaTeX, rob.tex, and it says some stuff. And now it says output written on rob.pdf. So if I open rob.pdf, let's see what that looks like. And there's our first LaTeX document, right? So we produced a PDF. Okay, so that's not particularly astounding. Any good document is going to need things like a title. So we might say minimal and an author. This, so we'll give it a title and an author, and then I just recompile this LaTeX and open it up, and something didn't work. Uh-oh, what did I do? What did I do, Justin? Oh, no, and I forgot to say make title. More magic incantations. Okay. So again, some of this you're going to have to just accept as magic to begin with. The nice thing is that the LaTeX thesis template also includes, in addition to the class file, a minimal thesis, and you can just start deleting sections and adding your own. Okay. So now I've started. I've added a title. I've added an author, and I've got some some stuff going here. So the next thing that any good thesis is, of course, is going to be something like sections, right? So here I'm going to add some sections. Now, how might you add a section if you were just to guess? Yeah, so you might think, let's try that, right? So here, what I'm going to say is I'm going to say here, this is section. I'm going to call this the introduction. And then down here, I'm going to add something that says section results. Now, of course, you can have sections and subsections and subsections. So here, I'm going to call this a subsection, and I'm going to say, this is what we did. And I'm going to say, this is what we should have done. Some stuff and not much. Okay? Whoops. Got those backwards. And if I compile this and open it back up, now I've got some sections. Now, one of the things to note here is that at any point did I type, the number 1, or did I write 2.1 or anything like that? No, I didn't, right? LaTeX is figuring that out for us, okay? Again, this might seem trivial, but it actually turns out to be really, really handy when you get into much more complicated documents. When you add a figure into the middle of a 200-page thesis, it's really nice if LaTeX figures out how to readjust everything dynamically. So of course I could change these sections. So say that, oh, I really didn't want results to be section 2. Results really comes after the background. So there is really no one who has done anything like my thesis before. Okay. And if I do that and recompile, I'm now going to have results as section 3, and it magically figures out the rest of it. Okay, so that's the idea of sections. All right. Now, I mentioned that one of the advantages of LaTeX is that it's customizable and scriptable and so on and so forth, right? So we're all computer scientists, and we like to make our life easier. Let me give you one example of how we might make our life easier. We can define our own commands in LaTeX. You can think of this as like a macro. And I could define a new command here. I'm going to say new command. I'm going to say my new command is going to be /rbev. And wherever there's rbev, it'll print out Robert Beverly was here, like that. Okay? And so down here, I can then use this, and I can say in my introduction, I can put an rbev, and then maybe in my background there's an rbev, and of course down here I'll put an rbev. All right, so now when I go ahead and compile this, and I look at my document, now I've got Robert Beverly was here, Robert Beverly was here, Robert Beverly was in a couple of places, right? So now why might it be useful to define your own macros and things like this? Yeah, so if there's something that's repetitive. Let me give you an example from like literally 2 days ago. I was writing a paper for IMC, and I'm writing it with 3 other authors, co-authors, and none of us could agree on the word endpoint, right? Is it end space point? Is it end with no space? Or is it end tack point, right? So since none of us could agree on it, we simply replaced within the text any instance of where we were using endpoint with /EP, and then at the very top of the document, once we finally agreed to something, you would just change one line, and then it does it within the whole document, right? So the idea there being, since there was 4 authors, and one of us used end space point, and one used end tack point, and one used endpoint all as one word, at least it's consistent, and we can change it in one place. Captain Rye had a question for me the other day. I can't remember what it was, but it had something to do with, I think it was ASs, and how do we do that? And I said, well, I don't know which thesis process you're going to get and what their particular philosophy du jour is, but if you make it at the beginning of your document, then it makes it really easy to change it throughout the whole thing. But even more fundamentally than that, one of the things that I'd like to point out is that LaTeX really is scriptable and customizable. And what that means is that I've known folks that have gone to the extreme of making a makefile. Everyone's familiar with makefiles, right? Where what they've done is they've got a makefile, and they type make, and it goes off, and it runs their experiment. And that experiment generates lots and lots of data. And all of that data gets written to files, and their makefile takes all of that data, wraps it up into a bunch of LaTeX, and then writes their paper for them, right? So this is kind of cool for a number of reasons, right? That I don't want to rat hole on. But you can imagine that you might want to write like a nightly cron job that sends out a report that's a really nice PDF for your boss, right? That contains the results of, last night's network congestion or whatever it might be, okay? You can literally get to that level of customizability. Now, I am told that such things are possible in Word with some bastardized combination of Visual Basic and stuff like this, but I believe it would be really hard, okay? So this is just, I'm not saying that you'll need to do this, but you should be aware. So I've looked at a paper, and maybe the paper got accepted, and the comments from the reviewers said, oh, we like what you did in this experiment, but twiddle this parameter. And I go back and I try to generate the initial data that I submitted for the paper, and I can't even do that, right? So having some way of doing, self-documenting, self-generating papers / code is really a useful thing, I think, for folks. And beyond this LaTeX tutorial, something to get into a good habit of in your thesis, right? Whether that's a README file, a make file, or whatever it is, make sure that you clearly write down your whole workflow and how you did every little step. So what's next on my list? Okay, so I did a, lists and enumeration. So LaTeX here we can say, of course, we can do standard things such as lists and enumerations. So for example, if I want to do a list, how do you think I might make a list? So a list here would be, for instance, a numbered list or a bulleted list. I often ask my students in their thesis, I say, give me a list on your first chapter of your contributions, right? Like if someone's going to read nothing but skim your thing, it's very hard to read a whole bunch of text. It's really easy to skim to the list of my contribution 1 is this, so on and so forth. So how might we do a list like that? Yeah, so from the HTML type idea, it's the same kind of thing. Here we're going to say begin, and we can either say begin itemize or begin enumerate. Okay, so I can say we'll do itemize just for fun, and then I'm going to end itemize, and here I'm going to have an item, and I'm going to say this is the first thing we studied. Then we went off on a wild goose chase. But came back to something reasonable, like that. And if I then generate my document, I can open this up, and now I've got a list with some bullets. This is the first thing we studied, so on and so forth, like that. Okay, so that's going to be lists and enumeration. Okay, labels and indirection. So this is a very useful and important topic. Okay, so again, as computer scientists, we often do things like labels and indirection, right? So any of these objects within the document, whether it's an equation or a figure or a table or a section, we can give it some sort of label. Okay. And what I might say is, why might I want to do that? I might want to say somewhere in chapter 4, I might want to say, as we explained in section 2.6 of the background, this is how this system works, right? Well, obviously I don't want to write 2.6, right? Why do I not want to write 2.6? Because if I subsequently changed a paragraph somewhere, maybe it's no longer 2.6, right? So we want some sort of label, and this gives us some indirection. So here, what I could do for the background is I could say label, and here, this can be any string. I use a convention where I say label, and I say sec background, like that, when it's a section. That just helps me remember it. You can use anything that you might want. So down here, in the results, we can say something along the lines of, as alluded to in section ref sec background, we really did look at the prior work, even if you don't think we did. Okay? And so when I build this, I'm going to now have this, where it says, as alluded to in section 2, right? So again, LaTeX just figured this out. And if I were to move this background section, let's move it to the end, because maybe we have a rhetorical style where we really like talking about the background at the end, and I run this again and generate it. Now I'm going to see here, as alluded to in section 3. So again, it just figures everything out. So this is super handy. Yeah, Justin.
You want to mention why you compile the voice?
No, because I think the tech maker does that for you.
Want to mention what the tilde is for?
Yeah, so the tilde, Mark is asking about here, where I said section tilde ref. Okay, so what the tilde does is I don't have to have that there. What the tilde does is that it ensures that it tells LaTeX I don't want to put a line break between those two things. So that's just sort of a stylistic tweak. For instance, it's a little bit disruptive to the reader to be seeing like section, and then it's the end of the line, and then 1 over here. So it keeps these things together. If it happens. Yeah. It's a minor thing, but something that you can get into. So
it's a good practice.
It's a good practice, and it actually speaks to the fact that as a beginner, there's a lot of things that you may not care about, okay? But LaTeX is also highly customizable. You can, really influence its behavior in a lot of ways, and this is a way that you might want to influence its behavior. Okay. All right, so moving on. Okay, math mode. So one of the nicest things about LaTeX is math mode, and I'm literally not exaggerating when I say that when I converse with my colleagues over email or something like that, and I'm trying to talk about formulas and math, I often use math mode, right? And there's a reason for that, right? It is an unambiguous way of relaying in ASCII text what an equation might be. And this gets complicated if you've ever tried to do it, without being able to specify the way things look or the precedence and so on and so forth. So you'll run into many math people in addition to computer science that have used LaTeX, and this is one of the reasons why. So math mode allows you to sort of unambiguously specify equations. To do this, how do you think I specify an equation? Well, there's a bunch of ways to go into math mode, okay? The simplest way that we'll talk about today is to simply say begin equation, yeah. And then, of course, I need a corresponding end equation. Now, anything between these two is going to be in math mode, okay? So in math mode, I can do things. I'm not going to have time to talk about everything that you can do in math mode. So suffice to say that you can do everything that you might want to do. You can represent the entire Greek alphabet. You can represent summations and products and integrals, so on and so forth. So maybe we'll say something where we want to do one of Gauss's rules. And so we can say something like, we'll do a sum. So this would give us a big sigma, okay? And when we sum things, we typically sum from, say, I equals, or n equals 0 to something, right? So what I can say here is I can say I'm going to sum, and then this underscore is going to be what's under the summation sign. And then I'm going to have a tilde that's going to be what's above caret, which is going to be what's the superscript as opposed to the subscript. All right. Now, for each of these, I'm going to put their corresponding value within these braces. And so what this means is that what's in these first braces is the subscript, and what's after the caret in the braces is going to be the superscript, right? So for here, I could say for, n equals 0, I equals 0 to n, something like this. And here, what I might say is I'm going to make a fraction. I'm going to say frac, and I'm going to say n plus 1 over 2. All right? Like that. Now, if I render this, I just want to show you an example. All right, so here's my first equation, which is going to sum the integers. Whoops, it's supposed to be an I. I screwed that up. Like that. I'm messing this all up. So what I was wanting to do was, sorry. Right, so this is going to be of I equals, like that. All right, there we go. I wanted to sum the integers. So if I do that, sum up all these integers, now what I see is that here, this I equals 0 is what I put in that subscript. After the caret was the n, summing I, and then here's my fraction, n times n plus 1 over 2. Okay? And so it makes it really easy to communicate equations. And you can do lots and lots of stuff with that. Anything else that you guys want to know about equations? I don't want to rat hole too much on it. It's like we could spend an entire day just talking about math mode. Is there any math that you guys would be interested in your thesis?
I just wondering, can the labeling also be used for math, not just for sections?
Absolutely, right? So here we can do things like begin equation, and we can say label, I would say, EQ Gauss, and then here I could say, as shown in equation tilde ref EQ Gauss, summing integers is as easy as like this, and then I can rebuild this, and sure enough, yep, there we go. So equation 1, like that. Okay. You can also go into math mode by using the $sign. Yeah. Okay. And I could say, I equals 0, L dots, and like that. So I will just point out that you can go into math mode if you do it correctly. Within the text itself. For instance, here. Okay, so you can do math within the text without making it an explicit equation that you refer to. And there's lots and lots and lots more stuff you can do in math mode. But I'm going to leave it probably at that for now. There's an entire document to check out. So if your thesis is math heavy, this makes your life really, really easy. I've had to swear at Microsoft's math editor several times in the past. Okay, so any thesis, of course, is not going to be good without some figures, right? Well, maybe it could be good, but figures always help people understand what's going on. So here, what I've got is a figure. Now, how did I generate this figure? Well, it's going to be this very LaTeX Unixy type philosophy, right? We don't care. We don't know. It could have been generated by GNU plot. It could have been generated by matplotlib from your Python analysis program, right? It could have been generated from Gephi, or it could have been generated from Inkscape, okay? I will say that it's often better to try to do graphics that are vector-based as opposed to bitmap-based. So if you just want like a free and open source picture editor, I usually tell my students to do something in Inkscape. So here, what I've done is I've generated a PDF. I've called it mod2, and it shows the finite field, okay? And so this I generated using an external program, and I've got a PDF. Now, what I might want to do is to include it within my LaTeX document. Yeah?
Do they need to be PDFs whenever you include figures, or can it be any file format?
For the purpose of your thesis, I'm just going to say PDF.
Okay.
I'm going to declare it a rule.
Thanks.
That is not technically true, but for you guys doing theses, just do PDF.
Yeah. PNGs are good, but like JPEGs are possible, bitmaps are possible.
No, they're not possible.
But
Impossible. You cannot do it.
But not possible in this room.
Okay, so now what I want to do is I want to include this. Okay. Now to include a figure, I am going to say begin figure, end figure, and then I am going to remember how to do it. If I can find it. There we go. All right, so I have to look it up. All right, so the first thing that I'm going to say is include graphics. Say mod2.pdf like that, and I'm going to give it a caption. All right. Well, so that would be a good chance. So say that I fat fingered it, right? Now, just like a programming language, what happens when Rob fat fingers? It's probably going to throw some, what's that?
Inscrutable error.
Yeah, inscrutable. It's going to throw some incomprehensible error. This one's not too bad, right? This one's actually saying L55, include graphs, right? And it's saying undefined control sequence, right? So that one's not too bad. It's actually telling me where to look on line 55, and I can go and check it out, okay? Like that, all right? And I can give it a caption. And again, Justin, I can give it a label and refer to figures, so on and so forth. assuming I can compile this. Probably because... Now, all right, so it's giving me an error. And the reason is because I forgot to tell it to do something. So in your Python, you may have done things like import sys or import math or things like that. There's an exact analog in LaTeX. So there's lots and lots of packages out there. In the NPS thesis, it already includes basically, unless you're doing something non-standard, everything that you could possibly want, okay? But since I was starting from the zero, I forgot to include the package that allowed me to add these figures. So up here, I'm going to say use package graphics, like that. And now hopefully it works. Okay, so that's why I got that error. You won't have to do that. It'll just work. All right. So now when I do this, now I've got a figure here. Okay, and it's kind of off to the side. So I could do things like I could center it, centering. And something else I might want to do is to change the size of this. Okay, and one of the nice things about PDFs and things that are vector graphics is that they scale very nicely and they still look good. And so in order to do that, I can do things like, yeah, I can say Resize Box. And again, you don't need to know this other than it's magic. If I don't screw it up like that. And I can hopefully generate one of these that's a different size. And I forgot a brace here, like so. And I can't spell, which also doesn't help. Okay, and TechMaker will make your life a lot easier. You won't have to go through all this. So here I've done two versions of the exact same figure. So here's my original one, and then here's the big one, because this is a thesis and we want to make an impact. Okay, so all of this is not to say that you need to memorize how to do this. I'm just trying to show you what tech is capable of. Okay, clearly you're not going to remember how to do all of this syntax, but it's all possible. All right, so we're almost done. So now we have done figures. So one of the things I mentioned was citations. Citations are really, really nice in LaTeX. Now, why are they nice? Well, let's say, for instance, that I wanted to reference Dr. Gondry, because he's done some amazing stuff. Actually, let me not do this. Let me do this. If I look at this and I put in Mark Gondry, and I look at his papers, now down here I'm really interested in fixing federal e-voting standards, and maybe I want to cite this paper, right? So I'm going to click on Cite, and it gives me a few options here. Now down here at the bottom is this link called BibTech, okay? And if I click on that, it's going to give me some text, all right? Now what I can do is simply copy and paste this, and in here I'm going to create something new called a Bib file. So here, what I might do is make a new file called sites.bib. I'm simply going to put Mark's paper in there. Okay. So now, in rob.tech, say that I want to actually refer to Mark's work. So in the background, I can say, oh yeah, there was this one guy who did something, but you know, it sucked. And then cite. Now, how am I going to refer to this thing? It's the same thing as the labels that we've seen before. Here, this is an article called Bar 2007 Fixing. So up here, I'm going to simply say cite that. Okay. Now I might want to probably put the tilde and some other stuff in here, but that's the basic idea. Okay. Now, what you're going to find is that there's lots of different, there's a whole nother syntax for BibTech, okay, that defines things like in proceedings, books, journals, articles, you know, all sorts of different stuff. One nice thing here is that we're not going to have any typos, right? we've simply cut and pasted it, so we're going to be able to refer to it exactly like the author we think wants us to refer to it. Okay. Now there's one last bit of magic that I'm going to have to put in my paper, and this is simply this is something you won't have to do because the base template of the LaTeX file that you're given for the thesis is going to contain all of this. So now if I generate this and I run bibtech on it, which again you won't have to do, I'll run this one more time. So now I should have here, it says, oh yeah, but you know it sucked, and it'll reference 1, okay? And down here we have our reference 1. Okay, and that's how I'm going to make my references and my citations really, really painless to slam in there. And in fact, one of the really nice things is as a researcher, you can start accumulating a bib file. Okay, so like I have a master bib file of like all my stuff, right? And whenever I need to refer to it, I just cite this. There's a whole bunch of papers in my field that I frequently cite. Just have them all in there. Just because those papers are in your bib file doesn't mean they're going to appear in your thesis, right? It's only when you actually cite these things that they actually appear. And you can also put comments in your bib files and make them it's a good habit to put comments in there that says, oh yes, this paper talks about blah blah blah, but it has this, and so on and so forth. Okay, so the very last thing.
You'll notice that the bibliography data got manipulated for the style. Like what Rob put in said Earl bar or bar comma Earl, and this changed into reordering and it's E-bar because that's what the style mandated. And so if that style changes, you don't need to do anything. You just rebuild with the new style.
And practically for you guys, excellent point, practically for you guys, one of the things that the thesis processor obsesses about is the format of citations. And so there's been a lot of smart people that have spent a lot of time encoding those rules into the reference style that NPS wants, basically, okay? And so when you guys go to Google and you slam something in there, it's just automatically going to render it in the way that the thesis processor wants 96 times out of 100.
And it's why you can have this master bib file for everything because the metadata is clean and the style files figure out how they want it to be presented for all the different places.
Exactly so. Now the last thing that I want to do before I let you guys go is to change this document class. And this is to highlight the fact that I'm not going to change anything in my document, but I'm going to get a completely different looking output. Okay. So what I've done is I'm going to change this document class, and for SIGCOMM, they asked us to use this class called SIG Alternate 2013. So I'm going to slam that in there. And now I'm going to rebuild this thing. Okay, and now I have a completely different looking paper, and it almost looks like a paper now that you might see in one of your classes. Okay, so this is that exact same paper. All I did was change the style file from the article to the SIGCOMM because that's what SIGCOMM wants for submissions, okay? And so it's done a bunch of different things. It's done things like changed it most noticeably from 1 column to 2 column. It's going to change the way the references are. It's put in this copyright block, and it's done a whole bunch of other things that control the spacing and the formatting. And instead of having a 3-page paper, now I just have this 1-page paper, okay? So again, hopefully you can see that I've focused on the content and not the formatting. It's freeing, and hopefully you guys can enjoy it as well.